All right, everyone. Sorry about the technical difficulties at the beginning. I had a little trouble getting things going, but it looks like we're up and running now. So we are going to take a look at, we're just going to go through the review assignment. But if you have questions on a specific problem on there or any other type of problem that we have, feel free to let me know in the comments and I will get to those questions when I can. Okay. Um, so the first one we're going over is a simple single fraction solve. Okay. And what you want to make sure you're doing anytime you're trying to simplify a fraction or simplify even multiplication of fractions too, you want to make sure you're factoring first. Okay. So first factoring we're going to do is pull up a different color here. We're going to factor the top by taking out a greatest common factor. And we're going to factor the bottom like it's the door problem. So we're doing numbers that multiply to the last and add to the middle. 4 times 3 is 12. 4 plus 3 is 7. Okay. Now, you are going to have to factor the top a little bit further. One of the big problems that I often notice in this type of problem is after people take out the 7, they forget to leave it as a part of their problem. It is a part of your problem still there. Okay, so make sure that you don't just divide things by 7 and get rid of it. You have to leave it as part of your problem. And what you can hopefully see now is that the x plus 3's cancel, and this is totally okay right here for your answer. You can leave it like that. That's totally okay. You can distribute the 7 if you want. All of it is good either way. Okay. On to the next. So here's basically just, honestly, this next problem is really just an advanced example of it, of the one that we did first. Okay. So really, instead of factoring and canceling within one fraction, you are going to be factoring and canceling in two fractions. But in the end, as long as things are in your numerator and denominator, you are welcome to factor anything you like. We have 3 different kinds of factoring within here. Okay, so the top left is a door problem. So we're going to factor that to x, x plus 9 and x minus 5. Those are the 2 numbers that multiply to the last and add to the middle. And then we're in the bottom right, we've got a squares rule. So that's x minus 9 and x plus 9. Okay. And then the other 2 places, we have a greatest common factor. Okay. So we've got a greatest common factor of 3 and a greatest common factor of 4 in the other 2 places in our fraction. So now we're just looking at what cancels. X plus 9's cancel. We are allowed to cancel diagonally. Okay, that is totally okay because they're in the numerator and denominator of the fraction, and it's multiplication. That's the key, had to be multiplication. We're also still allowed to cancel within that same fraction, so we can cancel the x minus 5's. Final answer-wise, it'd be better if you put these all as one fraction. So one option is to go 3x minus 1 over 4x minus 9. That is okay. You can do that. You could also do distributive property and do 3x minus 3, 4x minus 36. Both of those answers are totally acceptable. It's up to you. Okay, now we get into the interesting stuff. Okay, and what's interesting here is that we can't just cancel. Okay, we do have to get a common denominator because it's the subtraction of 2 fractions. Okay, the same thing is going to be true when we get here to 36 minus x squared, each over x minus 6. And even this one to a certain extent, and that one too. So like there's several problems in here. Anytime you see addition or subtraction of the fractions, you do have to get a common denominator. What's challenging about this one is that there's no easy way to get a common denominator. Okay. So for this particular one, the only way to get a common denominator is to multiply the second fraction by x minus 1 and multiply the first fraction by x minus 3. Okay. And what you have to do, and this is the hard part, is I'll leave my color the same for right now. There are parentheses around all of these. Okay. So if you're multiplying, for example, x minus 9 and x minus 1, you have to distribute the x and you have to distribute that negative 9. Okay, so both have to be distributed. We've called that FOIL before, first, outer, inner, last, for the 4 multiplications that you're going to do. Okay, so taking a look at what this looks like on our next line, this would be x squared minus 6x minus 3x plus 18 over, I'm not going to do the multiplication in my denominator. You don't need to. The only thing that matters is that your denominator is the same. And what you have to understand is you're never going to actually subtract your denominators. That piece is just going to stay the same. So there's no real reason for you to subtract, for you to do that multiplication. But you're going to need to in your denominator, or in your numerators, excuse me, because you're going to be subtracting and putting those things together. Okay. So once you get to this point, you have a common denominator. All you have to do is just subtract. Okay. The key is, again, just like we've seen in other places, that numerator is in parentheses on both sides. Okay, so when you see that subtraction sign right in the middle of the 2 fractions, you're going to be taking things on the left and subtracting on the right, even if there's a negative involved. Okay, so first thing I would do is I would combine those like terms. Okay, so over on this side, those make negative 9x. Over here, those make negative 10x. So now I'd just be subtracting my like terms. So x squared minus x squared is 0. Those cancel out, right? X squared minus x squared is gone. So I'm going to cross those out to know that I just did that. Now, be really careful. I'm doing negative 9x minus negative 10x. I'm going to write that out up here. You don't need to do this. I'm just writing it out because it's hard without me seeing you guys and without you guys seeing me. So I want to make sure you understand what I'm doing. So the term on the left is negative 9x. The term on the right is negative 10x, and I'm subtracting them. That's where that additional subtraction sign is coming in. Keep in mind, when you're thinking about that in your head, it's like those both become a plus sign. Okay. So that turns into just x. And then, much easier, I'm doing 18 minus 9, which is positive 9. All of that goes over my common denominator. Now, the great part about this answer is, even though it was a little bit of a pain to get there, there's no simplification I can do because I can't cancel the 9 with the 3 or the x's or anything like that because they're all in parentheses with addition and subtraction, so there's nothing I can do there. Here we're sneaking back to a single fraction simplification. If you'll remember, we did one of those right at the beginning, okay? And the key was we had to make sure everything was all factored first. The difference here is that all the factoring is done for you already. That's kind of cool. So now we just have to figure out what cancels. I'm going to go green. A plus 4 and 4 plus a cancel. They're the exact same number. A minus 3 and a plus 3 do not cancel. There's no canceling involved there whatsoever because those will pretty much always be different numbers, okay? So like they don't cancel in the same way. However, 2a minus 1 and 1 minus 2a, they do cancel. But when you cancel subtraction, that's kind of in that opposite order. Okay, so we flip that subtraction. It cancels to a negative 1. And that's because those numbers, anytime you flip subtraction, will always be opposites. Now, where you put that negative 1 in your final answer is up to you. You could go negative 1, a minus 3 over a plus 3. This would totally be fine. You could also do distributive property, get negative a plus 3 over a plus 3. There's several options that you have. Any of those answers are great. Now we're back to subtraction. Hopefully you kind of noticed that slightly unusually, they have a common denominator already. So there's nothing really for us to do initially. All we got to do is put those together. Okay. So those are now together. And now you're just looking to see if you can simplify. So now we're back to a single fraction. What we have to remember when we're trying to simplify a single fraction is that everything's got to be factored. My numerator factors into 6 minus x and 6 plus x from squares rule. And then 6 minus x and x minus 6 cancel with each other. But again, it's that flipped subtraction that cancels to -1. So you could either leave your answer as -1 times 6 plus x, or you could distribute and make it -6 minus x. Either of those answers would be just fine. This one was probably the trickiest one on the review by far. And the reason I think it's the trickiest one is because there's multiplication and subtraction. So that in and of itself is a little bit of a problem. And we're doing this weird fraction times parentheses thing. The way to interpret this is turn it into x over x plus 1, we're going to leave that, times 2x plus 2 over 1. So the key is that the 2x plus 2 in parentheses, it's like multiplying by a whole number, okay? So you want to put that over 1 so that multiplication works out okay. There's lots of ways you can go at it from here. The key is, though, you want to do all you can with that multiplication first, okay? So what you want to do is try to simplify that as much as you can before dealing with the subtraction. So the way I'm going to do that is by taking out a GCF of 2 and turning that into x plus 1. By doing that, I can now cancel my x plus 1s because that's multiplication. So now I'm left with x times 2 over 1. Well, that's just 2x. I'm going to bring down my minus 2x, and I subtract, and I get 0. There are many, many other possible ways that you could handle that problem too, but I think trying to simplify as much as you possibly could is definitely the easier choice, because then you don't end up needing to get a common denominator. Just really quickly, one way that you could have tackled this, I know I've seen people do this before. Instead of doing that factoring up there, they multiply together the 2x plus 2 and the x and get 2x squared plus 2x over x plus 1. Then you got this minus 2x over here. And then people ask, well, what do I do from here? And what you would do is you would get a common denominator, okay? So if you want, you could get a common denominator by multiplying by, oops, that's not right, by multiplying by x plus 1 over x plus 1. And you'd get 2x squared plus 2x over x plus 1. And go figure, you'd get the exact same thing over on the other side. So then when you subtract those two fractions, that's why you get 0. Okay. So checking over in the chat window, a couple things that I've noticed have popped up. Apparently you guys were just chatting about random stuff before I got in there. And then, yes, Adam, that is the review packet. Thank you, Noah, for helping out on that. Is that going to be on the test, Jackson? I'm not sure specifically which problem you were referring to, but this is a review packet, so any of that is fair game. And then we made some jokes about donuts, and Jackson wanted us to count how many times X is said. Okay, super fun. So Jackson was apparently talking about this particular problem on there. Yes, this could be on there, but this would definitely be one of the harder ones. Oh yeah, those do look like donuts. Hilarious. Okay, moving on. Another subtraction problem. So here's the deal. Anytime you've got addition or subtraction, you absolutely need to get a common denominator. Okay, with this one, it becomes a little bit tricky because you got to factor your denominator first. So that factors into x plus 4 and x minus 1. Okay. This is different from our equation solves. We're not trying to get our denominators to go away because honestly, we can't. There's no other side of the equal sign to kind of balance things out here. So really what we have to do is get a common denominator. We're going to do that by multiplying this first one by x plus 4 over x plus 4. After I do that, I'm going to get 2x plus 8 over x plus 4x minus 1. Same thing over here, except not a whole lot I have to do there, just rewrite. Oops. Okay, so now once you've gotten a common denominator of x plus 4 times x minus 1, all you got to do is subtract your numerators. Okay, so 2x minus x is x, and 8 minus 9, remember, that's in parentheses, so you got to do 8 minus 9, not 8 plus 9, 8 minus 9 gets you minus 1. Then at the very end, these x minus 1s do cancel. We are able to cancel those, okay? And so what you get, on top you get a 1, because remember we're doing division when we cancel. So those are dividing out to be a 1. And then we leave it as 1 over x plus 4. You don't need the parentheses. You can have them. It doesn't really matter. Yeah, so Jackson asked a pretty good question here. You can do whatever as long as you do it to both so it doesn't change the value. Yes. Okay, so what we want to be careful of is when we don't have an equal sign, we want to make sure whatever we're doing to either the numerator or denominator of a fraction, yes, you want to be doing to the other. So that's why I multiplied by x plus 4 and x plus 4. Okay. When we have equations, we'll see that the rules maybe are a little bit different because we can do the same thing to both sides of the equation. But yeah, definitely with fractions, you want to do the same thing to numerator and denominator. The long division problem. Okay, so I already wrote this in terms of long division. So I put that 4x plus 3 on the outside. I'm going to try to walk through the steps as best I can. So really what you're doing is you want to remember you're always dealing kind of with those first terms, okay? And the second term doesn't come into play until you're dealing with the multiplication. So when you're figuring out what number to go on top first, you're figuring out 4x times what gets you 12x cubed, okay? And that's 3x squared. 4 times 3 is 12. X times x squared gets me the x cubed. Now when you're doing the multiplication piece, okay, so normally in long division, when we put a number on top, we then multiply by what's on the outside. We're going to do 3x squared times 4x. There's our 12x cubed. And then we're going to do 3x squared times 3 to get 9x squared. Okay, then we're subtracting. Okay, so we're doing 12x cubed minus 12x cubed to get 0. And we're doing negative 19 minus 9 to get negative 28x squared. And then we're bringing down the next one. Yes, this is for sure going to be on your test. There's no getting around that, okay? But what I will say is you should absolutely use calculators when you're doing your subtraction here, okay? Because the biggest thing that people tend to mess up is that they tend to have a hard time getting the subtraction just right, okay? So what you want to do, like when I did, I'm going to pull a different color here so we know what the heck I'm talking about. When I pulled these, okay, and I was doing that subtraction, like I would just strongly suggest you type in negative 19 minus 9 into your calculator, right? Like that is gonna help. Okay. I think it's a lot of the issues we have with this one, and maybe I'm wrong, are really having to do with dealing with subtraction and negatives and all that kind of stuff. I think that if you rely on your calculator to help you out with some of that stuff, it makes it at least a little bit easier. Okay. And actually this one, to be honest with you, is probably a little bit on the harder side for something I'd give you guys. I'd typically try to make the numbers maybe a little bit nicer to work with. Okay, so now continuing on. once after you brought the next thing down, you are doing the exact same thing again, okay? Except now you're working with the 4x and the negative 28x squared. So you're doing 4x times what gets you negative 28x squared, okay? And you do want the negative, okay? So you're going to put negative 7x up top, okay? Once you start dealing with negatives, you do have to be a little bit careful, okay? But you're doing negative 7x times 4x. That's going to match, give you the negative 28x squared. And then negative 7x times 3 is negative 21x. Okay, again, you are always subtracting, okay? And what's a little bit, makes this a little bit better maybe, is that those first two are always going to subtract to 0. Right? I got negative 28x squared and negative 28x squared. They'll subtract to 0. Over on the right, when I'm subtracting my x's, I would strongly suggest you type into your calculator negative 25, then a subtraction sign, then negative 21. So I'm typing in the exact subtraction I'm doing except without the x's, okay? Because that'll tell me what number goes out in front of x. If you type that in, you get negative 4. So we're going to get negative 4x. Bring down your minus 10. And then you're just repeating one more time. Let's go. This orangey colors looks nice. Okay, so now you're dealing with 4x and negative 4x. So you're asking yourself 4x times what? Gets you negative 4x. And that is negative 1. So that goes up top. Do your multiplication. We get negative 4x minus 3. Okay. And then again, do your subtraction. Again, at the end, I really suggest you just type stuff into your calculator, okay? Make sure it's top number minus bottom number. So in this case, it'd be negative 10 minus negative 3, okay? And that gets you negative 7. And then what we do with that remainder is we put it over 4x plus 3, what we had on the outside, okay? So really, it's pretty much the exact same steps as regular long division, but you just want to make sure you're being really careful with your subtraction, okay? And your multiplication too, but your subtraction, that seems to be the one most people, when they say I'm lost on this, most of the time it honestly is a subtraction error, and then the numbers get kind of crazy pretty quickly, okay? Last one. This one should feel a little more familiar because we've just done it recently, and it's solving, okay? So when you're solving, really what you're just trying to do is you are trying to get rid of those fractions as quick as you can, okay? So what you want to do on this one is basically figure out what would my common denominator be. Now we have to go in with the understanding, and I'm going to erase this a little bit, then put it back. You want to go in with the understanding that that is 5 over 1. So that does not have a common denominator, okay? So the easiest thing I found to do is just pick whatever your common denominator would be and just multiply to get rid of it, okay? So I'm going to multiply everything by x minus 2. And this is where I can do something a little bit different than what I can do with just without the equal sign. I'm allowed to put these just in my numerator because I'm doing it to both sides of my equation. If I don't have a second side of my equation, then I have to do the same thing in my numerator and my denominator. Okay. The benefit of doing this is I can cancel those. Now I'm just left with 8 minus x right there. Over on the other side, I've got still 5 times x minus 2. I'm going to do the distributive property there. All you're trying to do from here is now isolate x, okay? So I'm going to add x over to the other side. I get 8 equals 6x minus 10. Then I'm going to add the 10. I get 18 equals 6x, divided by 6, x equals 3. And we could go ahead and check our answer if we really wanted to. We've got 8 over 3 minus 2, so that would be 8 over 1. 3 over 3 minus 2, that'd be 3 over 1. So 8 over 1 minus 3 over 1 is 5 over 1. Yes, Ian, that is on the test. That seems to be everybody's common question. We actually did this in class on Friday too. Okay. Folks, if you're good on all of these problems, you're definitely good to go for test. I would say that the long division problem that we did here was probably maybe a little bit on the challenging side. The one thing that I would watch out for on test tomorrow is, let's see if I can pull up a good example. Oh, here was a good one where you have that flipped subtraction that cancels, and just making sure you put a -1 in there. Okay, so like when we canceled in this one 6 minus x and x minus 6. You want to make sure that when you're canceling those, you cancel those out to be a -1. Okay. If you have other questions, I'll be around tomorrow morning. I don't think anybody has a test until after recess. So if you have like actual questions or something like that, you can probably come in then too, and that would be fine. Okay. Thanks for hanging out for a little bit. And no, Jackson, I do not have a gaming channel. That was pretty weird. See you later.